Hey guys, and welcome back to another video. For this video I have a math lesson, and the math lesson is symmetry. So, behold today's agenda. First, we'll go over vocabulary. Second, we'll go over identifying symmetry. And third, I have a practice problem, which is just symmetry practice. So for vocabulary, of course, we need to know what symmetry means. And my definition for symmetry is when a shape or figure can be made up of the exact same two parts. Or actually, I'll hold this thought off for later because I use the phrase multiple times later. And if that definition doesn't make sense right now, it will after I tell you guys how to check if a figure has symmetry, which will basically check, as the definition says, if it can be made up of the same two parts. So there is one main step. It's a long one, and it's to look at the figure from different angles until you find one that has the same part twice. And this is the phrase I was saying that I would hold off from later. When you cut it in half, that's basically what it means. You just need to check if you can cut it in half or draw a line through the shape to make it so that it shows two equal parts. If this is not possible after looking at the figure, then this shape is asymmetric, which just means not symmetric. So, before you guys do that practice problem, I have one practice problem that I'll do first, and it's to circle each shape that has symmetry. Cross out each shape that does not have symmetry. Okay? Let's use this color. Alright, so let's look at the first shape. Does this first shape have any way we can cut it in half and make it have the same part twice? Well, yeah. When you cut it like this, sorry, that's my best drawing, the top and the bottom are the same, so we can circle it because it does have symmetry. Let's take a look at this. Once again, we can cut it in half like this, and it's the same part, so we can circle it. This one, just cut it down here, and these two are the same, so it does have symmetry. This one, cut it down here, and it's two triangles. Now this one. Well, let's see. What happens if we cut it right over here? Well, they're not equal because this one has this extra triangle part that's longer than this triangle part. So we can tell that if we cut it that way, it doesn't have symmetry. But sometimes, and in many cases, there are multiple ways a figure can have symmetry. So let's not just stop there. Let's check it from a different way. What happens if we cut it here? Well, no, because it has this extra triangle again. So, if you guys would keep going that way, I can already tell, hopefully you guys can too, that this figure does not have symmetry. So we can go ahead and cross out this shape, just as in the instructions. It says to cross out each shape that does not have symmetry. Alright, this shape, cut it like this and you get two semicircles. This one, just cut it in half here, and you get two more rectangles. This one, notice how these are both trapezoids, but for this one, if you do it here, they're both the same. Sorry, I've been forgetting to circle. But notice how if you cut it like this, for this trapezoid, it's formed symmetry, but this one does not, because this one has a extra right angle here, instead of this triangle shape sort of at the end. So that's why one of them has symmetry and the other doesn't. And that's gonna, I'll give you a hint now, it's gonna play a big role in the practice problem. This one, right over here, and you get these two more of the rhombuses. This one, it seems like it doesn't have symmetry, guys. But, look. You can do it like that. So don't just like, okay, let's say for example, instead, we decided to go ahead and do, okay, let's try over here. No, this one's a sort of square, and this one's just a rhombus. I guess it doesn't have symmetry, but we have to look at it at all angles to check if it has symmetry. So if we check on this angle, we see that it works. It just sort of tilted to make it look a little hard. So these shapes also have symmetry. So only one shape didn't, which makes it a little easy, but it's good to see if each shape has symmetry. Okay, now I have a practice problem, and this problem requires some general math knowledge to solve. So why don't you guys go ahead, pause the video, and solve. Okay, hopefully you pause the video and solve this problem, because I will now go over the answer. So let's read it. Addison is thinking of a shape. It has one right angle, two pairs of parallel sides, and 4 sides. Does the shape that Addison is thinking of have symmetry? Hint. It's a common shape, so it's not like one that's not really a shape. So, first we need to identify the shape. The shape has 4 sides, meaning it is a quadrilateral. 1 pair of parallel sides, meaning it is a trapezoid. And we know this because the hint says it's a common shape. And it is a trapezoid with 2 right angles. So we can assume the shape looks like this. See? This is the extra right angle. We also have this one up here. Now, because of the fact that it has 1 right angle, it is asymmetric, like we did in the practice problem, like that one I did with you earlier, no matter how you look at it. The story would have been different if it looked like this, because for this one, we can just cut it in half like this. This is like a trapezoid with 0 right angles, but it also with symmetry. Anyway, the answer is no. There is no symmetry in the shape that Addison is thinking of. Well, that's all for symmetry. In the next video, I'll go over another topic based on this called rotational symmetry, and a few more topics after that, which are just more into symmetry, but more advanced, you could say. And I didn't include it in this so it wouldn't be too long, and I just decided to split it up into 2 videos. So make sure to come back to my channel to watch that video. Thanks for watching. Bye.